Multiplying monomials over polynomials. Our first example, we'll start with something like 3x squared y times 2xy plus 3y minus 5x cubed y squared. So the first step is to actually do as it implies, multiply across these. We look at our regular numbers, our coefficients. 3 times 2 is 6. And then x squared x would be our base exponent ideas. Common bases mean we add the exponents. So we can call this x cubed. Just like with the y, it's common bases, so 1 is 2. We can call that 6x cubed y squared. In a similar way, we distribute to the second term. 3 times 3 will be 9. X squared, and then again we have this y, which would be y squared. The last term, which was outside the parenthesis, just gets rewritten. And then at this step, what you're doing is looking for like critters, like terms, combining like variables. And so when we look at this, notice that this is a label of x cubed y squared, x cubed y squared, meaning that we would be able to combine those two terms together. And so you have 6 take away 5, which would be 1. And as we've said in our last lesson, when you're adding and subtracting like terms, the labels don't change. So we can call this x cubed y squared. And then we would say plus 9x squared y squared. Again, the concept is that when you multiply, the exponents will change, but when you add and subtract, you cannot change the label. You create no new animals. And so in this case, 6 take away 5 was just the 1, x cubed y squared, and then we had the 9x squared y squared. Because those were different, you couldn't add your final answer as a binomial. That's example 1 for multiplying monomials over polynomials.